Welcome to this course on Spring Boot. Nice to having you here. But before we dive into Spring Boot itself, we need to take a step back and first look at Spring itself. Because without Spring, there's no Spring Boot, and without understanding the context in which Spring emerged, it's hard to truly grasp why Spring is the way it is today. The year is 2002. By this point, Java is already an established language in enterprise software development. The standard for developing enterprise applications in Java at this time is called J2EE, Java 2 Platform Enterprise Edition. J2EE provides much of what you need for enterprise applications: database access, transactions, web interfaces. Sounds good, right? So the only problem was J2EE was incredibly complex. As a developer, you had to write a huge amount of infrastructure code before you could even implement a single line of business logic. You can see a concrete example of this right now on the screen. To write a simple component in J2EE that accesses a database, you had to create a class that implements a specific interface, fill in several lifecycle methods that the server calls, even if you didn't want to use them at all, and describes the component in an XML configuration file so that the server even knows it exists. All of that just to be able to execute perhaps 10 lines of business logic in the end. Your actual task, namely solving business problems, was quickly lost in the noise of this complexity. This really was absolutely no fun, I can tell you. This is where Spring comes in. Rod Johnson, an Australian software developer, published a book in 2002 in which he described these shortcomings in great detail while proposing a different approach. From this approach, Spring emerged. First as an open source project, and later as one of the most influential frameworks in the Java world. The core idea behind Spring was incredibly simple. Your code should focus on your business problem, not on infrastructure. Spring takes care of that infrastructure. That sounds almost obvious, but at the time it was a real paradigm shift. In concrete terms, this meant, for example, that as a developer, you no longer had to write heavy components tied to a specific server. Instead, you could write completely normal Java classes, so-called POJOs, plain old Java objects. Take a look at the comparison on the screen. On the left, the J2EE component from earlier, with all its infrastructure overload. And here on the right, a simple Java class with only a single method and a simple member, a POJO, no infrastructural glitch. Both solve the same business problem, but the difference in complexity is more than obvious. Spring takes care of managing these simple classes, connecting them to each other, and providing them with the necessary infrastructure. We'll take a very close look at exactly what that means in the next few lessons. Spring has evolved tremendously since then and is now far more than a single framework. It is an entire ecosystem of projects covering a wide variety of requirements, from web APIs and database access to security and much, much more. We'll also take a look at an overview of this ecosystem. But first, let's look at the heart of Spring, the concept that makes Spring what it is in the first place: inversion of control. We'll get back after a short break.